Okay, one of the last functions that we're going to implement here is called flatMap, and I want to show an example of its use first in case you're not familiar with it. So in this example, we're taking our sequence 1, 2, 3, and we're going to flat map it with f, and then turn it into a list, and we should get this list back. So the f function that we're giving it takes in some element of the sequence x, and then transforms it into another sequence, and we're building the sequence using a list. So that's why the of list appears here. And effectively, we're kind of just going to like duplicate each of these elements. So this returns a sequence. So flatMap is sort of like map, except at the end, after you map stuff and turn it into lists, you kind of concatenate all the lists back together. So the overall effect of this is that we've taken our sequence 1, 2, 3 and duplicated each of the elements and concatenated them back into the same list. Okay, so to define flatMap, we're going to make it recursive. FlatMap. Okay. And it's going to be a function. The first thing it's going to take is it's going to accept the function, so f, and the type of this function will be, it's going to take in some element in our sequence, and it's going to return a new sequence, sort of a nested sequence, and potentially of a different type here. Okay, and then we need our sequence of A's, so T of tick A. And overall, this thing's going to return a sequence of B's. Yeah, okay. So let's get our switch. So the first thing is we're going to actually call the sequence, the first function in the sequence, to get, if it's nil, then we return the empty sequence just like usual. But if it's cons, we'll have some x, and we'll have the rest of the sequence. And now we need to call f on x, and the return type of this will be a sequence. So f transforms x's into sequences, and then we sort of just need to concatenate this into the rest of it. So it's like if we had the append function, that's how you write append in ReasonML. We would sort of just append the result of calling flatMap with f on the rest of the sequence. So this is going to generate, an entire list as well, but we just sort of concatenate both of them together. Unfortunately, we don't have this append function for sequences, so we're going to have to write that ourselves. So, all right, let's write an append function, and this is going to take two sequences, so we'll call it seq1 and seq2. And it's going to return another sequence of A's. Okay, and we're going to switch on the result of calling seq1. So we're going to be sort of it's going to be recursive on the first list. So if the first sequence is done, then what do? Then we can actually just return all of sequence 2. So, if you append the empty sequence onto a full sequence, we just get the second sequence back. So I think we can just say sequence 2 here. Okay, and then if we get something, an x, and the rest of the sequence, then then we're going to need to return a function, and we'll be consing x onto the result of appending the rest of sequence 1 onto sequence 2. Okay. So the only thing we've actually done here is we've just reduced the problem size by 1. So instead of appending two, a sequence of size n onto another sequence, now we're just appending a sequence of size n minus 1 onto the smaller one. And eventually this is gonna get us all the way down to the nil case. Okay, so then we have our append function and we can actually use it. I'm going to define a nice little infix operator. So maybe instead of at, we can just say at tilde. I don't know, that looks lazy to me. So, and we'll just call this append. Or, we'll assign it to append. And then all we need to do here is just use our append function right there.